Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email ratnesh721kumar721, that is here. And then I will send you that detailed info that how my students they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down um, the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab. In 4.0, we have infrastructure services. Let me show you the content. We have to understand the basics related to console, VTY, telnet, HTTP, HTTPS, etc. Then you can see the topic related to SNMP and other services and features. What I have planned, I'm going to cover all these sections one by one, subsection wise. So the first section is 4.1 console and line VTY. I have created two videos here to understand this topic, to understand the theory plus lab as well. So please go complete these two videos, and we are very much covering 4.1a. Once we complete this 4.1a, in next section I will go and start 1.4.1.b. Okay, so please complete video number 93 and 94 to complete 4.1.a. Right. So when we are talking about the basic security on Cisco routers, when any user, any remote user, try to log into the device, so how we are going to provide the line security. So line VTY, what is the transport for that line VTY? If we are using telnet, then what type of security we can do? What type of even privilege also we can assign to the client? What type of access they have to the devices, each and everything we can go and configure. So suppose if we have line console, line aux, you can go and give the password. Again, if you go and check show run, you will find that these passwords are visible. So we can do the encryption of the plain text password that we are giving to the device. So if someone can see the show run, they can't see the password. So that's the reason we have the option for the enable password. We have option for the enable secret. These are the password when we are logging into the device. So say you have done your telnet or SSH, and then you want to gain the, or you want the access for the privilege. So at that time you can go and run the plain text password, or you may have the secret password. Recommended is that we should use the enable secret, that will do some MD5 hash. Here you can see in the show run the MD5 password, that's enable secret CCI. I'll show you this MD5 hash. This very difficult to crack. Again, if you give normal password, then it's not recommended. And suppose if you have two password, enable password and secret password, so the enable secret will take precedence with the plain text password. If you want to encrypt each and everything over the device, means all the plain text password over the device, then we can go and run this service password encryption. It will go and encrypt all the configuration. Here you can see that initially this enable password was Cisco, and now it is showing some MD7 hash or MD7 format. Okay, although this MD7 is very easy to crack, there are so many online URLs you can go and put this, and it will give you the password. So at the moment you'll go and put, you'll find the password as a Cisco. So that's the reason. One recommendation is that your password should be mix of the alphanumerical or different type of characters. So even if someone try to hack that, if someone has the MD7 try to resolve that, it will be difficult for them to figure out that password. All right, so in next section we are going to perform the lab for this. Let us perform the lab task. We have the topology here. You can see R1 and R2, and over R1 we'll go and enable the telnet SSH and all sort of password encryption. So let's go to R1, and I can go to line VTY says 0 to, say for example 1, and here we can go and give, say, password Cisco. Then from R2, and we have point-to-point IP configuration. Let me ping to R1 first, and then I'll try to telnet. And here you can see that the telnet port is open. Password is Cisco, so I can go and use Cisco. Because I haven't set the enable password, so I'm not able to log in. Here it is telling that authentication to privilege 15 is failed, because by default we have the privilege level 15, but we have option that we can go and set different type of privileges. Alright, so what we can do here, that we can go and do the enable password, again say Cisco. And now if you go and choose this enable, and if you type Cisco, you can see that we are inside R1. We can go and check the users. So here you can see this is the user who has logged in. Now once we are logged into R1, and if you go and check show run, you will find that we are using the plain text password. So for VTY 0 to 1, the password is Cisco, and we are using login. Again, if we go and check show run section enable, so here you can see that the password that we have is the Cisco, and it is in plain text, correct? Now if you want to check both the password, you can see here. Now to encrypt all type of password that is in plain text, we can go and do service and then encryption. Let me check if we have service. Let's see that what option we have, but we can go here and do this password encryption, and then if you go and check the output, you'll find that all the password that initially was there in the plain text, they are going to be encrypted. Although to break this encryption is very easy, we can easily go and break this encryption. So what we want here, that we should not use the enable plain text password, rather than we can go and use the secret password, say for example 123. And now if you go and do the telnet, and then if you give the telnet password is okay Cisco, but the enable password is Cisco 123. Okay, now if you go and check the enable password, you'll find that it is hashed, MD5 hashed. So that's the one thing that we can do. Now what other things that we can go and do with line VTY, say for example 0 to 1 or 4, that we can do here no login. That means login is not required. This is not a recommended way to do this, but what we can do, that we can do login local, or you can see that you have option that login, and then you can go and use say login local. So these options we have. Login local means that now you can define the username, say for example admin1, and then you can give the privilege, say for example 7, and password. Again you have option that you want to use the unencrypted or the hidden password, correct? So for example I'll go and give Cisco as a password. Again I'll go and change the privilege as 10, password Cisco. So now I should change the admin 1 and admin 2. So now I have two admin and they have different level of privilege, correct? So if I go out from here and try to telnet with username admin1 and password Cisco, I can go and check the privilege level. And now if you try to get the output, even you don't have show run option, and if you try to go to conft, you don't have those options. Again, if you go and do the telnet with admin2 and password Cisco, and you can go and check the privilege, you have privilege 10, and if you go and to show run conft, those things are disabled, correct? So again, that's one level of security that we are discussing at this point of time. Now, not only this line VTY, but we can go and give the password to line console as well. We can go and give the password for line aux as well. Okay, so like that we can go and give. Now these are the password related to telnet, related to enable password, and then the we have learned about privilege as well. Now what about SSH? Because when we go to line VTY 024, and if you go and check transport input, you have this option all, or you can go and use SSH, and that is the standard. So we should not use telnet, rather than we should use SSH to all the devices. So if you want to enable the SSH, you should go and define the domain name, and then you should create the crypto key. So crypto key generate RSA modulus 1024. Now once you have the domain name, once you have created the crypto key, if you want, you can give the SSH version as well. In this example, I'll give version 2. And then you should go to line VTY 024, and already we have done that configuration. So let me show you that configuration, what we have done related to SSH. So now this configuration that you have, the input and output, everything is related to SSH. Now I can do the SSH with the local user, say admin1. Okay, and what's the IP? Okay, so I should use SSL admin1 10.1.1.1, and then the password is Cisco. Now you can see that directly we are logging to the device, but if you go and check the privilege is still less. So now you can see that we are giving tighter security. We have started with line VTY plain text password, then we have given the service encryption or password encryption, then we have configured the line VTY with normal username, then we have given the privileged username, then we move to the SSH, and inside SSH we have given the privilege level. So we should use or we should follow this practice, that is much more secure. Now what is happening in industries is that we are doing all this authentication, authorization and accounting for all the users from the ICE server or from the ACS server. At the moment, the standard is ICE, Identity Services Engine. So in upcoming section, you will learn and understand more about the use cases or use how we are going to use the ICE for the all these operations. In 4.1b, we have topics related to telnet, SSH, HTTP, HTTPS, and SCP. I'm going to cover telnet and SSH in this recording. We know that if we want to do the remote access to the devices, we have telnet and we have SSH, both the methods. We are preferring SSH because we know that telnet is not a secure way. In telnet, you are not securing your password while you are remotely accessing the device. All the devices, they have line VTY option. Some devices have 0 to 15, some have more than 15 or 16. Means 0 to 15 means 16 user can be accessing the device at a time if the telnet is open, if the SSH is open, etc. Okay, but there are some prerequisites. Means while we are doing the configuration, um, we have to set the enable password, we have to set the login password, or maybe those login password are authenticated via AAA. So options are there to secure your remote access. You can see that you can create your local username password as well. Username, give the name, then the privilege and the privilege password, etc. Okay, or these databases that can be authenticated via IC as well, ICE or AAA as well. How we can do the configuration? Straightforward. If we are creating the local DB, username Cisco, password Cisco, means Cisco is not a good password. So while you're giving the password, you should use long string mix of different type of characters. Line video 0 to 4 and then transport input telnet. Okay, that's it. Since this is not a secure method, so we are always looking for securely remotely accessing the device. So we have SSH version 1 and SSH version 2. SSH version 1 having some issues, vulnerabilities, some exploits. SSH version 2 is quite secure. Now, while doing the SSH version 2 configuration, again, there are some prerequisites. You can see that you should have the host name, you should have the IP domain name configured, you should generate the crypto key. Okay. After this session, I have one small 5-minute video related to how you can do this basic configuration, and then from automation tool or any tool, you can go and remotely access the device if you have the IP reachability. Okay, once you do the configuration, some verification commands are there, show IP SSH, show SSH, etc. that we can go and check. So how we can configure it? Give the router name, give the IP domain name, give the username and password, and then generate the crypto key, go to the line VTY, and then make sure that transport input while the dialing inside is SSH enabled. Okay. Great. If you want to do a little bit of SSH modification in the configuration related to SSH, you can go to IP SSH, give version 1 or 2. Then you can go and set the IP SSH timeout, authentication retries. Okay. And then over the line VTY, we can go and use the transport input as a SSH or as a all, etc. So options are there. Next video, do the SSH configuration, you please go and watch the next video for the lab example, so you will understand how we can do the SSH. So we have the switch here. Let me go and start this. Switch number 1 and switch number 2. So what will happen that first of all, we should log in to the switch via the SSH, because if we do not log in, then obviously we can't send the uh, script. Now, when we are talking about logging to the switch via SSH, so in that case, we need to go and do SSH related configuration. So first of all, we should go to line VTY 0 to 4, and we know that we have the login local here, and transport input, your SSH should be there. But anyways, we are giving all that, means we are covering SSH telnet, means all type of remote login. So that's first step. Then we should go and define the domain name, say IP domain name. For example, I'll give cisco.com for the time being, and we should create the crypto key. So crypto key generate RSA modulus 1024. Because in case of SSH, this crypto key that we are generating, this public key, should be authenticated or should be accepted from where we are going to do the SSH. Okay, so what we have done, that we have given the IP domain name, we have given the crypto key. Now if I go here and do the same, so in the meanwhile, let me go and create the template for the SSH. So when we are doing the SSH, we should have IP domain name. For example, here I am taking cisco.com and then crypto key generate RSA, and here you can see I can even copy this command and I can paste here. And then we should have a line VTY configuration that is already there. So here you can see the line VTY configuration, and then we should have a username configured as well. So let's wait when it will come back, then I'll copy and paste. Now once we have all these configuration, then what next I want to do is that I'll try that this device is reachable from the automation tool or not. And we know the IP is 192.168.122.2. So let's go to the automation engine and let me copy as well. Let's go here and try to SSH. We know that the username is Cisco. This is the password. We are accepting the key, and then password is Cisco. And now you can see we are in the switch. Okay, so same thing, I will go and enable. I think we need only these two lines because the rest of the configuration is there in switch number 2. So I'll go here to switch number 2 and we can go to the conft. We can generate that key and then I can go back here, and from here this time we'll go and do the SSH 2.3. Accept these keys and the Cisco, and we are inside switch number 2. In this section, I will quickly walk you through the other features that we have, other services that we have: HTTP, HTTPS, SCP, and FTP. Now, HTTP and HTTPS, there is fundamental difference in between that. So in HTTPS, you can see the keyword is S, and that is stand for secure HTTP. And when we are dealing with the organizations, we should focus on security as well. So that's one of the main reason you'll find that unless we have some specific use cases, most of the time we are preferring HTTPS. Some places where HTTPS is not supported and you want to use HTTP as a service, because these are the application protocols, then at that place you'll find that in configurations in industry people are using HTTP. But HTTPS is the recommended one because it is providing you secure sessions related to HTTP. HTTP, they are using port number HTTP, port number 80, you can see here. But HTTPS is using TCP port number 443. That's the secure port number that we have. Now I'm going to focus only on the configuration here because we know about how the HTTP and HTTPS is working. For HTTP configuration, it's very easy. Go to configuration mode, IP HTTP server. In the same mode, you can go and integrate with AAA IP HTTP authentication AAA. Now, when we are dealing about the secure HTTP, where the certificate will come into the picture. Suppose if you have 3 routers, or if you have big infrastructure where you have good amount of router, one of the router can become a CA as well. We have that feature in Cisco router that you can make routers, they can work as a root certificate authority, root server, root CA authority server as well. Okay, and you can see the configuration related to that. So IP HTTP secure server, crypto CA trust point. Suppose he's the CA, then enrollment URL. So any other device they want to enroll with that CA, because before doing any type of IPsec type of configuration or creating VPN type of tunnel, they will get the certificate from the CA server, and then they will form the IPsec in between the devices. Even here also, even here also. Yep. Then crypto CA authenticate CA trust local, crypto CA enrollment CA trust local, and IP HTTP secure trust point CA trust local. These are the standard configuration when you want to make your router work as a HTTPS server. That's the CA server. Then next topic is SCP. If you want to securely transfer the file, we can use the secure copy protocol, and we should integrate this with AAA. You can see the configuration: AAA new model, AAA authentication login default local, AAA authorization exact default local, and then the username Cisco privilege 15 and password 0 Cisco. Is these configurations that we already know from our AAA knowledge. Okay, this is not new. In AAA, we know that how we can configure the devices respective for uh, switches, routers, ASA firewall. There you have to put the AAA configuration like that we can do. But there are so many other AAA configuration. This is just the standard 3-4 lines. Then for SCP, IP, SCP, server enable. So the point being here is that our routers, they are working supporting as a HTTP, or our router working supporting HTTPS, or our router working supporting SCP, Secure Copy Protocol. Likewise, our router can work as a TFTP or FTP server as well, file transfer protocol. So you can store the files inside the routers. That's not the recommendation, because you should use some third-party servers, and because they're third-party servers, you have good amount of storage. When we are start storing the files inside the routers or switch, boot flash, or inside switch, that is not a good practice, but sometimes we are doing this. Okay, so in that case, we can go and enable it. Now you can see that FTP is using port number 28, and TFTP is using UDP port number 69. Okay, with FTP, they have different type of port numbers. So you can see that FTP uses TCP port 21 for authentication and TCP port 20 for data transfer. Two ports are there, one for authentication, one for data transfer. Then the configuration, we can go to the router, TFTP related configuration, TFTP server flash file name, copy TFTP flash. For FTP configuration, IP FTP, we can give the username and password. So if anyone is coming logging there, they should give the username, password, and then they can use the FTP resources. Okay, so these are the important services. Let's stop here. Hi there, thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. In part or two, we have to understand about SNMP. I have created playlist related to SNMP. You will understand the SNMP, what is SNMP, the MIB version, the SNMP configuration, SNMP lab, SNMP lab result, and quick revision. So please go complete this 1, 2, 3, 4, 5, 6 videos, and you're very much completing subsection 4.2 related to SNMP. We have the management protocol for the network. That's the simple network management protocol, SNMP. Let's first of all understand the terminologies used in SNMP. Basically, we have three main or major component. We have SNMP manager. You can think this as a collector where it is getting the information from the SNMP agents. So you have agents, that's the network devices, and you have manager where all those information are getting collected with help of MIB. So third very important component, we have the SNMP management information base. Now what is happening? Now these MIBs are nothing but the information that is stored inside the agents, and managers, they are using get, that means to retrieve the information, and suppose if they want to change certain parameters they can use set. So managers, they are using get and set methodology to get the information, or if they want to change anything they can change. Now again, the communication channel we have, we'll see that we have versions of SNMP. So for example, community based version, SNMP version 1, SNMP version 2C, and then we have something like authentication or user based SNMP methodology as well, that is the SNMP version 3. But yeah, we have different version as per different RFCS standard, and these SNMP or the SNMP protocol in general, they are used to collect the information for the management purposes. So for example, what type of information? Say interface monitoring type of information or protocol monitoring type of information. Now one of the popular tool for SNMP at this point of time we have, so for example, third party SolarWind tool, where we are going to do the testing as well in the upcoming lab session. Uh, Most of the production network, they are using SolarWind, or there are various tools as well. Just they are using SNMP methodology, same methodology that you have manager, you have agent, and then MIB, and then they are collecting information at a common place again for the analysis purpose. Now here you can see that the SNMP get method, we have three type of get method, means we are getting the method, we are getting the information, we are getting the next variable information, or we are getting the information in the bulk as well. So three get methods inside get method we have. And finally we have SNMP notification as well. Now what is SNMP notification? This is again a type of information, and it is referred as a unsolicited asynchronous notification that can be generated as a trap or information. So in the configuration, I will show you that we can use the methods, the agents can use these methods to tell the manager about the various type of information. So in trap or maybe in inform, you have various type of information that you want to tell to the manager, and in the configuration I'll show you that what exactly trap look like. Now we have trap and we have inform. Most popular in these two is trap. That is less reliable as well. So what is happening actually, what's the uh, core difference or basic difference between trap and inform is that trap is a message that the manager is getting, that don't have any acknowledgement. On other hand, the inform, they have the acknowledgement as well. So that's the reason the trap is faster, or trap methodology is faster than the inform method. But yeah, inform method is reliable because it has its acknowledgement as well. So we know the basics terminology used in SNMP. Let's stop here, and next section we are going to study about SNMP MIB and versions of SNMP. Let us understand Cisco MIB and versions of SNMP. Now this MIB is nothing but a database, and this MIB is in form of tree structure. Uh, Again, if you want to learn more about MIB, you can go and refer these RFC 1213, and for traps we have 1215. And even with respect to Cisco, if you want to again see the tree structure and the hierarchy, you can go and check Cisco MIB, and you'll get long list of MIB related to most of the things. So for example, the informations related to protocols, the information related to traps, the information related to flaps, information related to CPU, interface, monitoring, etc. etc. And again, major vendors, say for example, who is working on SNMP, Solar Wind and others, they are using this MIB, and they have the SNMP manager where they can go and collect all this information that I'll show you in the uh, upcoming session, that how you can retrieve these informations, how you can query. So suppose if I have SNMP manager, I can send the query. That's nothing but the get method. I can send that get method, and once I do this get method, the responder, that is nothing but the agent, they will give me all the information that I query inside this string. Okay, now we have three versions. We have version 1, 2C, and version 3. 1 and 2, SNMP version 1 and 2C, they are very much community based. So obviously they are doing the community based authentication. The method of authentication is the community string. Again, in the lab section, we'll see that we have the community string. Even we can put some sort of ACL, ACL as well for that if we want to filter out the uh, number of volume or number of requests we can put inside the ACL. That we'll see in the lab section. Then we have version 3, that's the secure model. We have version 3 is supporting, say for example, message integrity, authentication, and encryption. Now there is a huge improvement with respect to version 1 versus 2C, and you see that still most of the organizations, they are using community based version 2C. Why? Because they can do bulk retrieval of data. That's obviously the tables and large quantity of information. Again, these are uh, belonging to the tables. Whenever we are talking about tables, they are belonging to the database system. So maybe MySQL or any type of databases that these managers, they are using behind the scene. So maybe they can use MySQL or any type of database, depending upon those company and their partnership with the database companies. All right, so version 2 can get a large volume of data with less amount of expense. Expense here means the memory, the round trip delay, etc. That's the power we have with respect to 2C versus SNMP version 1. And when we are talking about version 3, this is based on the security model for users or users belonging to group. Now, what is the difference? I have this slide for that. Here you can see that we have model, we have label, authentication, encryption, and what is going to happen. Now, version 1 and 2C, we know that they are community based, so that's why we have the community string for obviously authentication, but they are no auth, no priv, no auth, no priv, no authentication, no priv. Uh, Again, I told you that community is itself a type of a string, or you can think a password, just to do the authentication, but it's not exact authentication like you have MD5 SHA that we used to learn inside various other protocol like IPSec and others. Okay, but still you can think that community is a password, or it's a authentication way of protection to do the authentication between the agent and the manager. So for inside V3 again, V3 just not only supporting the authentication and the encryption, but they have uh, no auth, no priv method as well. So you can do username. So user the username match for the authentication. Then you have auth, no priv. Auth means authentication, no privacy. At that time you have the MD5, maybe SHA. At that time they will go and do the authentication. And finally it has auth and proof, where you are using both the MD5 and DHCP as a data encryption. Okay, so these are the versions we have related to SNMP. Let us understand the configuration, and obviously we are going to do the configuration in lab. Now, when we are doing the SNMP configuration, we can go and give the SNMP contact location chassis ID. Then we can go and verify as well. So for example, show SNMP contact location and chassis. Now, when we are configuring version 1 and version 2, we know these are the community-based versions. And what are the prerequisites then? How we can go and configure? So the prerequisite we have that we should follow these, at least these three things, that who is the manager, and we can put those managers in ACL and what type of roles they have, like read only, read write, etc. Then if we want to cut down the SNMP MIB view or MIB view, just to protect, to get too much information. Obviously what is happening that you have agent, and suppose you have 4 or 5 different manager, or obviously different IPs, means you have different managers at different location to pull those information. So pull those MIB information related to network management. Now if you put too much load on a network device, means all the time they are giving so much information to all the managers, there are chances that the CPU spike will be very high. So there may be issues related to CPU, maybe issues related to memory, maybe issues related to congestion. So unnecessarily do not burden your device with full MIB, and that's one of the thing that even the best practice, that we can cut down the MIB database and we can create views, and then that view access will be um, through, or that view access through the community string or through the community, or sometimes we are referring community as a password as well. Then we can have the read and write permission. So three things: define the manager with ACL, or maybe if you have only one or two manager, then simply you can go and give the manager IP. Define the view if it is required, if you are facing issues related to a spike, CPU, etc. And then we can go and give the read write permission to the community. We'll see that in the lab section, that how this configuration template look likes. Now you can see that's very easy: SNMP server, community string, view, read only, read write, then ACL number. If you want to uh, shut this down means if you want to remove the SNMP, you can go and use no SNMP server community. Again, we can go and check show SNMP community. Now, if you want to give that notification message in terms of trap, so for that we can go and put these configuration here. Either we can go and use trap or inform. So here we can see the configuration is SNMP host ID, trap, inform, version 123, auth, no auth, priv, etc. All right. So in case of version 3, again, it belongs to user, or users belong to group, where we can have authentication and encryption. So we should go and define the group as well. That's why you can see here that we have SNMP server and group, and then group name version 123, auth, no auth, priv, that we have already discussed earlier, and notify and access list. Again, you can go and check with show SNMP group. So let me quickly log in to the lab devices, and let's perform the lab task related to SNMP. Here you can see the lab setup. So I have a switch, actually all these devices except this SNMP server. SNMP server is my local system where I have put the SNMP server. And then I have this host. This is nothing but a router. I have made this as a the display is like host, the laptop or a PC. These are connected with the Ethernet port with the router where I'm using the Ethernet switching capability. Inside VLAN 2, I will go and show you the configuration for this switch one, that is again the router. Just for the simulation, I have made this as a switch. So let me quickly show you the configuration for switch one interface F1/1415, and then the IP addresses of these host, so host 3 and switch 1. Obviously this is going to be my SNMP server. So what I will do, that I will go and pull the information. Okay, so let me show you all those things. Obviously we have to do the configuration for SNMP as well. So here I have, you can see I don't have SNMP configuration at this point of time that I want to put. And with this host, if I go and check show IP interface brief, what IP it has. So here you can see that I have interface 1/15, and who is the gateway? Gateway is dot 2, and where is dot 2? So that we can go and check where is the gateway. Gateway is the VLAN 2 actually. So here you can see that do I have VLAN? Switch 1. I don't have VLAN that I want to make it. So how I can do this? Say VLAN database name, if I can give, or maybe we can give like this, VLAN 2 name, just all right.
Thanks everyone for enrolling this course. In this course, you will learn all the technologies related to CCIE Enterprise. But in case you are looking and you are preparing for your lab exam, please feel free to contact. We are running some sort of 100% guarantee program to make you pass. I will provide you the lab, resources, everything. If you want to know more about this offer, you can go and email to this particular address. Anyways, in this course, you are going to learn all the technologies. This will be very useful course to you. But in case you are planning to write your lab exam, just feel free to contact us. We'll provide you all the guidance, all lab related tips, techniques, all the passing techniques, etc. So please do not hesitate. Feel free to contact us and we will provide you and we will assure you that you pass your lab exam in first attempt. Thank you.
Let us perform the lab task. Here you can see in the lab that I have one SNMP server that is again I'm going to use as a manager. And then the switch one that you are seeing here in the diagram, that is actually router 1 that I'm going to use as a agent. And then from this host I will go and generate the traffic. This host is also one router. I have made this to look like as a PC. Okay, so what we can do, first of all, let me show you the configuration for host 3 and switch 1, because anyways this SNMP server is my local system where I'm doing the recording for this session. So let's go and open the CLI. Here you can see this is actually the switch. So let me go and change the name. So this is the switch one I have, and if I can show you the gateway for all the PCs belonging to the VLAN 2, we can go and check show VLAN and then switch. Here you can see that I have VLAN 2 and these two interfaces, 1/14 and 1/15. They are belonging to the VLAN, that is VLAN 2, that you can see here 14 and 15. So the manager and the host, they are belonging to the access VLAN 2. Alright, so what we want to do here, I want to do the SNMP configuration for the switch. So I can go and do the SNMP configuration, say SNMP server, and then I can give the location, say for example ABC. then SNMP server, the chassis ID, and then SNMP server. We have the connection or something, contact. So here you can see contact is okay. And now you can go and check the show SNMP server or show SNMP contact or something. So these things we have seen. You can go and check this thing, contact, and then the chassis ID, etc., etc. What configuration we have done so far? Show run section SNMP. Now I have one template configuration. So here you can see some old configurations are also there. But here you can see that we have the template of configuration that I can copy and paste. Here in this configuration, you can see that the host that my local system has this particular IP, and I'm using the community name is this RATNESH. Again, I'm going to create one ACL, and inside that ACL, whatever IPs that I have, I'm giving read write permission. Okay. So like that, we can go and do the configuration. Even you'll find in the configuration we have more a number of traps and what is there in the ACL. So I can go and show you this access list where I'm giving permit any, but we can have the list of the managers in the ACL. Okay, so here you can see this configuration look like very straightforward, and then we can go and verify it. Okay, so how we can do the verification? I have one SNMP manager engine installed in my system. I can do the SNMP walk. So I am inside this particular folder in my local system, in my Windows system, and then I can go and do the SNMP walk. Here you can see SNMP walk.exe. Then you can go and give the version. That version is 2, and then I can go and give the community and then the SNMP manager IP. So that is 192.168.56.1. And now here you can see on top that the new window is coming up where I want to use the port, the timeout, the SNMP version. Obviously I should go and give the agent address. So my agent address is 192.168.56.2. That's the IP of the switch VLAN 2. I should go and give the community like this. Now here you can see this is the root OID. I can go and do the scan. Once I do the scan, you will see that it will go and download one text file that I can open, and I can show you that. Now, important thing here is that when we are doing this NMP walk, we should not have blockage for port number 161. All right, so I disable the firewall port in my local system. And now if I want to ping from here to my agent, that's again the switch we have in between. So you can see that I have reachability. So that means that I can go and do the walk. I should go and change the IP 6856.2 and then the string, that's the password. Scan. Now you can see the OID started scanning, and because we are using the root OID, although we have option that we can go and give the string as well. So here you can see that we have this output saved. Let me open this output. Let me open this. Now here you can see this polling, or you can say that this SNMP walk. You can see the OID and what it is doing. So we have the complete output related to interfaces. Let me scroll down. You can see the IP addresses. So we have interfaces, we have IP addresses, the status of the interface, but you can see that it's a long output we have, and that's the power we have with SNMP version 2, that it will go and take all those information that we have, although we have used the root MIB or OID to get this information, but it depends that what exact information you need. According to that, you can go and put the filters. All right, so this is the way that we can go and run the walk. We are going to do a quick revision about the configuration of various versions that we have. We have already studied that how we can go and configure the important version, that is version 2, and C stands for community. Here you can see that it's a straightforward. We can go to the global configuration mode. We can do SNMP community public. Again, it depends that what type of community is string I have, public, private, or if we have any type of restriction, we can go and use with certain ACL as well. So again, here you can see that you can go and give the host version 2C and host version 1 as well. If you want to limit the number of managers, you can go and give even the permission as well. For example, read only or read write, and then mapped with the ACL 4 where I have the group of the manager. Again, we can go and enable various type of trap. We have a long list of trap or notifications that we can go and enable. We can go and give the host in terms of DNS as well or URL as well. Now again, we have the use case related to version 3. We know that version 3 where we have the group or the users belonging to the group. We can have option if we want no authentication, no priv. That means that we want a user based SNMP version 3 configuration. So here you can see that you have to go here and define the group. So SNMP server group 1 version 3 no auth, and then we can go and give the user as a remote user part of group 1, and the remote server is 10.12.8.4, then SNMP server host, and there we have the informs version 3 with no auth, again the remote user config. So we can go and give the configuration like that. This is the case with no auth and no priv. Again, if we have case related to authentication with no priv, so again we can go and define the group with auth, and then auth user group remote version 3 auth MD5 password. Correct? Now again, if you have option or if you have use case that you want to give the priv security, so again we can go and define one group with the priv, and now I have the private user with group 3 with this remote location version 3, and again we have the authentication and the priv access. We know that the encryption that we are using is days 56 bits of encryption with days algorithm. Okay, so here you can see that it include everything, that it include auth and priv. You have the authentication, so here you can see auth MD5 password, and then you have the encryption as well, like priv access for this particular user, that is the private user. Okay, so this was the summary that what we have studied so far. In next section, we have to go and study about the Syslog, and we have a small lab related to Syslog. In 4.3, we have to configure the Syslog. We have to understand the debug and conditional debug. So please go complete these 3 videos, and we are very much completing subsection 4.3. Now here, one important thing we have is that we have different type of log messages. So what different type of log messages we have here? You can see that they're starting from emergencies going to debugging, level 0 to 7. So these type of log messages we have, and it is up to us that what type of log messages we want to see over that remote logging server. To set up that, we have option. We can go and use logging, and then the server name where we want to send these log messages. We can go and do logging buffer as well, means how much you want to buffer in your local system, how much you want to redirect. If you want to redirect all the messages, it's fine. We can go and redirect all the messages to the remote login server. Now, once we do that, at that time they are using the syslog messages or syslog server. The communication channel is over UDP port number 514. So if in between we have any ACL or any firewall who is blocking this port, we should go and unblock it. Now, if you want to see that log message is in different timestamp format, then we have option that we can go and use service timestamp log datetime, service timestamp debug datetime. So these commands we have to set the log message in millisecond, and it will show you the time zone as well. Now again, some of the commands, if you want to go and check the logging history, you can go and set the label here. You can see uh, by default, it is showing warning, error, critical alert, and the emergency. So here you can see that emergency alert, critical warning, and errors. So from 0 to 5, it will show. If you want, you can go and set the history label. Even we can go and set the logging history size as well. Okay, so let me quickly log into the system, and in that system, let me show you that how our lab look likes. In my local system, I install DNS, and here you can see that you have your server, you have your host, and you have your switch as well. So what I have done to examine the syslog message over the server, I have installed this TFTP, Jonin TFTP server, and inside that you can see that you have syslog server option. So if you go and click, at the moment we don't have any log message, so it is not showing anything. I can go here and I can set that. So I can go to the switch and I can give okay logging, and this logging I want to the server. So I should go and give the server IP as well. So let me show you these things parallelly. And here you can see that you have your syslog server. So I can go here and I can give logging 192.168.56.1, and then let's see that what other options we have. So if I can do logging buffer, and here you can see that in the buffer also we can go and give the label of the severity starting from 0 to 7. So I can go and give, say for example, up to 5, and here you can see this 5 is warning. Apart from that, if you go and see that what other options we have multiple options with logging, and we can see logging and then question mark. Here you can see that you have options. You can give the address for the remote login server. Buffer, you can go and set the logging buffer. Then exception facility, filter history. Here you can see that you have logging history, host, monitor, etc. So we have multiple option here. If I want to set the trap, and then again if I go and set the informational logging, and then here you can see that you have history. So logging history, and then here I can go and see set the size, history size say 200, and then finally logging history, and the uh, message is say for example informational. Alright, so once we have this log configured, we can go and check the logging, that what configuration that we have put. Here you can see these are the things that we have put. Now if we want to see this in the syslog server, so here you can see it has been started. and it is stored at this point, 192.168.56.1, and we should get that information over here. So let me go and set this syslog. So if I go to interface 1/5, and if I do shutdown, so we should see here the syslog messages. Here you can see that now it is showing over the screen, but I want to send this, and we should have the communication between my system and the logging server, which is not at this point of time. So let me see. 1/15 is down. So what I can do here, that I should bring up that interface 15, no shutdown. They should be up. Otherwise, there is no communication in between my log server and my local system. All right. So we can go and check the log configuration. First of all, it should be correct. And if I try to ping, it's not reachable. If I go to the system and if I try to ping from there to my local switch, let's see if I'm able to ping. Yep. So in between, if we have any firewall rule which is blocking the port number, it will not work. We should check, we should disable that firewall or allow that port at least. All right. So meanwhile, we can go and check the logging message here. And in the local system, you can see that we are getting some sort of messages. So what it is telling, let us see in the local system, logging to this audit disable, link is up, filter is disabled, and here in the local system we can see that yeah, we are getting the log messages. We should get this in the remote server as well. In my local system, I have disabled the firewall rule. Now you can see that from a switch I am able to ping to the TFTP server. Now let's try to generate the log messages. So I can go here to the interface 1/4, and if I do the shutdown for that interface, so at the moment it generates the log. Here you can see in the remote logging server, we are getting the log messages. Now if I go and do the no shutdown, again you will go and see that the log messages will come to the remote logging server. So this is the way that we can go and check the log messages. We have debugs and conditional debugs. We know that in Cisco routers and switches, we used to run debugs to know more about what is happening in the break scenario or what is happening behind the scene. But doing so, whenever we are enabling the debug, there is a chance that we can increase the CPU, obviously, because now you are getting all the informations about what is happening to that particular process. Again, Cisco has given one nice option that we can use conditional debug as well. Now, conditional debug is a way that we can prevent or protect from the utilization of high CPU and memory. We have certain commands to do that we'll go and check in the lab section. So what we can do, that we can go and enable debug. So for that, we should go to the exec mode and run debug, and then we have multiple options to enable that debug. We can go and undebug as well with the command no debug protocol. So enable the protocol or turn on the protocol, take the logs, do the analysis and turn off the protocol. Then we have so debugging option. With that we can understand that how many debugs that we have used, how many debugs actually are running in that device. Then we have conditional debug. So for example, I can go and use debug condition interface, and over that interface what is happening we'll get to know. Again, for the conditional debug, we have option to do the no debug for the conditional uh, debug, and conditional interface means debug over that interface. All right, so let me quickly log into the lab section and let me show you the lab topology as well. And then we'll go and enable the debug and we'll play around. So here you can see that I have my lab topology. It's a very straightforward lab topology where you have 4 routers and you can see the network as well. The router 1 has IP 12.0.0.0.1 and router 2 has .2, then 3 has 23.0.0.3, etc. So let me quickly log into the device, and first of all let me show you the IP schema that we are using here. So I can go and run the script, show IP interface brief, select all, send the script. So you can see the IP assigned to the interfaces. So for example, for router number 4, I want to create one loopback as well. So I'll go and assign one loopback address for our future troubleshooting and testing. So here you can see R1, R2, R3, R4. These are the IP addresses. So far, I have assigned only the IP addresses. Later on, we'll go and run any of the routing protocol as well. So what I want to do here is that I want to do the ping to router number 2, and whose IP here you can say 12.0.0.2. So even we can do like this. So I'm going to do the ping to 12.0.0.2. Here you can see that I am sending the ping packet and ping is successful. So what I want to do here, that I will initiate the ping, and I can do the repeat count more number of times. Then I can go to router number 2 and I can enable the debug. So what I can do here, debug IP, and here you can see at what options you have. So we have long list of protocols that is supported. What I want to do here, I want to do the debug for IP. So let me do that. Alright, so debug IP, and then again after IP also you can see that we have options related to so many things. Say ICMP. Enter. Now you can see here at the moment I enable the debug, I can see that echo reply. So this device is sending the echo reply, correct? You can see it is sending the echo reply, and it is so fast because it is coming from here. I can go and stop this. So let me go and complete that, and here you can see there is still whatever requested are there in the buffer, still we can go and see that. Now in this case you can see there is no chance that I can go and turn off the debug because already it is cached, correct? So what you can do, that you can re-log into the device, or otherwise you have to wait to that particular uh, point. It will come where you can go and stop the debug. So one thing you can see here, that at the moment I enable the debug, I start getting so many packets, correct? Now while it is going on, let me show you that what other option we have with the debug. Now it's gone seems, so I'll go here, and if you want to stop, you can go and use undebug all. Before doing that, let me show you that what debug we have on. So here you can see that it is showing that your debug is ICMP packet. Now if I go here and use IP packets detail instead of ICMP, and now if I go and show you show debug, now you can see that we have two debugs on. And now if I go and initiate the ping, while initiating the ping, let me reduce the size as well. So for example 3. Now you can see the debug is on and we are getting the output in detail. because we have done IP packet details, so we are getting the ICMP type and code that we are going to discuss in the upcoming session. So here you can see that with help of debug, we are getting much more information about the ping and what is happening behind the scene. Okay. Now, next what we can do, next we can go and verify the conditional debug as well. Now, before doing conditional debug, if we go and check the IP route, so I have created one IP route here for 2222. Say in router 2, I have one loopback 2.2.2.2. So for that, I have created one IP route statement that I can go to the next router and then the next hop. Great. So now if I go and enable, say, debug IP packet details, and if I go and do the ping for 22222, so you can see that we have flood of message. Rather than getting the flood of message, what we can do that we can go and create one condition, say for example IP access list standard or maybe extended, where you can go and define the source and destination. So I want to do, say for example, permit IP host. My source is, say, this, and then I can go and give the destination as 22222. Then inside the debug statement, I can go and use it. So anyways, if I am using debug on this router, I should use the condition here, correct? So I can do this thing. I can copy and paste this condition here, and even here also I can run the debug, correct? So no problem. So here also I'll go and enable the debug IP packets in detail, and here I'll do undebug. Say for example undebug all. Now I can ping to 12.0.0.0.1 with the source of 222, and I can repeat for example 4 times. Now here you can see that you have this debug. Again, you have long list of debug packet that you want to shrink or you want to minimize that. So for that we have this option. I can go and use IP debug packets, and then you can see that I can use the ACL, although I don't have option to apply the named based ACL, correct? So I can go and create the same thing with the named based number based ACL. So I can go and create, say, IP access list, not IP access list extended. I can give the number. So we know that the number, so 1333 is my number. Permit IP, who is the source, set let's give the source and the wildcard, correct? So IP is 12.0.0.0.1. Means the host, and then the destination. All right, let me quickly see that what's the issue. If I just wanted to use the extended ACL, and do I have number for extended ACL? Here you can see it's a little bit different than the other. I can go and give the extended ACL number as 100, and then I can go and give permit IP host 12.0.0.1 and then host 2222. Great. Then we can go and apply to debug IP packets 100, correct? Detail. And then if I go and do the testing, so from other side I'll go and ping. So I can come here and I can do that ping one more time. Here it is. Oops. And Here you can see that your table has decreased. So initially we have big table. Let me do that one more time. Now you are capturing the source and destination. Okay, so this way that we can go and use condition in terms of we can apply the ACL with the debug. The other variation we have actually is the condition. So I can go here and give the condition, and inside that condition I can go and match the fast Ethernet 0/1. Now you can see that one condition has been set, and then I can go and do the same thing. So let's do the ping. We can go and check here. So in this, what is happening that the condition will match only fast Ethernet 0/1. You can go and check the condition, and you can see that one flag has been triggered. So this is the way that we can do the debug. So I have shown you the normal debug, then debug with ACL, then also we can go and use the debug with condition as well. I have created the playlist for the rest of the section. Section 4.4 I'm going to cover once you go and complete all these sections. So here you can see that for section 4.5 IPSLA, I have created one video. You go and complete this video, that means the IPSLA section will get completed. Then for section 4.6, because we have to understand NetFlow, so I have created 3 videos in this playlist. So once you complete these 3 videos, subsection 4.6 will get completed. Finally, for DNA assurance, I have created 2 videos. So once you go and complete these 2 videos, your section 4.7 will get completed. So please go watch these videos, and we are completing subsection 4.5, 4.6, and 4.7. Next important topic we have Cisco IPSLA. Now, Cisco IPSLA is a mechanism in the existing WAN or in the existing network that is giving us the capability that dynamically we can track certain services, certain IPs, and according to that, dynamically again, it can change the path. So suppose if your primary link is down, then you can go via the secondary link, or there is other option as well related to loss, jitter, latency, etc. So let's try to understand this IPSLA workflow, how it is working. We're going to understand about IPSLA, its operation, and then obviously we'll do the configuration and we'll verify as well in the lab. Now, what features that IPSLA provide us? Here you can see that with help of IPSLA, we can go and understand and collect the parameters related to loss, latency, jitter, packet sequencing, path per hop, how it is going, and the connectivity. And according to these parameters, we can go and change it dynamically, correct? So how it look like, how we will go and configure it. We should go and enable the IPSLA. So for example, IPSLA 1, I want to check this particular destination. So what I can do that, say for example, I can send uh, the ICMP echo packets just to check that this destination is there or not. And suppose if I have multi-path, so if one path is down, automatically you will go and then because one path is already down, you can go via the second path. That's the overall idea behind this. So this frequency 5, that is the overall rate that we are sending the echo packets to the destination, that is 1111 in this case. We have started this IPSLA and it is a start now, and maybe we can give forever. So life forever is started now. And finally, we have to glue this with the tracking. So again, over the configuration mode, we'll go and enable the track 1 for IPSLA 1 for reachability. So what this track will do, it will start tracking this particular destination with the ICMP echo packet. Now how it is working behind the scene, again we'll see in the lab, that for IP route, with IP route actually, I have two IP route statement. We know that by default IP route has a higher AD value with respect to any other protocol, and then you can give some bigger AD value, say for example 30. So the best one is the first line. It will go and hit the first line, so this will be the primary, and then you have enable the track on this. So primary path with tracking, that is ICMP echo of frequency of 5. That means if this track is down, that means if destination is down, obviously you'll get this track is down, you will start going via the other link, correct? Now once you do this configuration, then we have the verification command. We can go and check show IPSLA application, SLA configuration, history and stats. So let me quickly show you the lab setup. So here you can see that we have the lab setup, and in this lab, say for example, this is my source and 111 over R1 is the destination. You can see that I can reach to R1, loop back via R2, and then I can go and reach via R3. So what configuration I have done? Obviously we have the IP assignment to all the interfaces, etc. Let me quickly go and open the putty. So I just wanted to show you here that what configuration I have for router number 1. So for example, at the moment the IPSLA is not started, and you can see that we have the IP route command, and we should go and check this R4 because R4 is the source generator. So I can go here and I can show you this. Let me quickly show you this IP route configuration. At the moment it is 3040, so this is the preferred and this is the backup. uh, Again, it depends upon what type of IP route statements you have. So what does it mean at this point of time with this statement is that 34.3, so this path, because you can see the IP assignment here, this is the IP, and then the IPs over these interfaces are of the range of say 24.0/24, and here the IP address is 10.1.34.0/24. So these are the IPs we are using. Router 2 means .2, router 4 means .4, like that we have the IP convention. Alright, so now here you can see clearly that with this rule, if I do and do the trace route for the destination, obviously it will go via R3. And now if I go and change this, say for example, this statement to 50, and if you check this now, so that means this is the lower, the traffic will go via this direction. Okay, and that's the case. What I want this traffic should go via this direction, and we should go and track this with IPSLA. So I can go here and I can enable say IPSLA 1, and then I can set the frequency and other stuff. So let's see that what are the other things that we can go and set here. So now you can see that once you go and enable the IPSLA, you have this ICMP echo. What is your destination? You want to check this, and to send the packets, you can go and use the frequency, so for example of 5, and if you have any timeout, you can go and use the timeout 1000. So what does it mean? That within 1 second, so its default is 5000, 5000 millisecond means 5 seconds, so frequency is 5 means per second you are sending one ICMP echo packet. Great. So once we have this, we should go and start this. So here you can see that IPSLA scheduling and a start time is now, and then the lifetime is forever. Correct. So once we have all the configuration related to IPSLA, we should go and enable the track as well. So what is that? Track, say 1, and then what you want to track, say IPSLA 1 reachability. Correct. Now since we have all this configuration, we should go and apply this track to the IP route statement. So what I can do here, first of all, let me delete this, otherwise you will find multiple entries. Now I can go here and then I can give track as 1. Now the track has been glued, and here you can see this track is glued with the IPSLA. When you can go and check the route, so you have 2 routes now. One is the primary, one is the secondary, obviously with the tracking. So now if I go and check show IP track, or let's try to check show track 1, and here you can see this track is up, it is working with a static IP routing. Now what we can do here, that we can go and shut down the interface, any of the interface that will not allow us to reach to this destination. So for example, E1/0 over R2. So I can go here, interface E1/0, I can do shutdown, and then you can go and check the output here on 4. So now here you can see this is track is down because in this direction we have the track. And now if you go and check show IP route, so you will find that the static route entry, so you have seen both. Now it is via 34.3, and the track is also up. So this is the way that we can go and verify the IPSLA.
Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email ratnesh721kumar721, that is here. And then I will send you that detailed info that how my students, they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab.
Now, as the IT evolve, and as we need to analyze more and more data with respect to security analysis, with respect to troubleshooting, with respect to network analysis, we need to learn and understand the flow or the record. So for that reason, we have NetFlow. And again, if you see the versions of NetFlow, you'll find that we have NetFlow from version 1 to 9. 5 is most important and actually most popular. Uh, Now, what's the difference? You will see the main difference here is that in version 1, we have less capability that we can analyze less number of field in the flow or the traffic flow. Rather than if you go and see, say for example, version 9, where you have much capability to analyze the flow, means we have much more option, much more capability to see inside the flow what type of headers and fields we have. We'll see that how many fields that we can analyze inside a flow in different versions. Now here you can see that, say for example, you have source and you may have destination, and then you are using NetFlow. So what are the things that you can check? Uh, Again, we'll see that we have multiple options to verify, but at least we can go and check the IP addresses, source and destination, the port numbers, source and destination port, protocol, packet send, packet receive, if you have any tagging related to source and destination, and then various TCP flag. Now, this information is huge because this is going to answer us 5 different Ws. So, who is sending means what is the source and destination IP, what's the port, where it is sending, what is the destination's IP, so who and where, again related to the addresses, what they are sending, so which application they are using, what are the port numbers they have, so who, where, what, how. Again, you can see that how many packets or bytes they're sending. So here you can see the packet counter, the byte counter, and when they are sending. That's the timestamp, at what time this transaction happened. So again, we are getting 5 W answer: who, where, what, how, and when. And that's important. That's important to do the analysis with respect to either security or network analysis. Now again, if you want to correlate this with the phone book, again you will get to know that net flow equal to the flow. Inside that flow, who, what, where, when, all these informations we are getting with respect to flow. Now the next important question is that which version should we use? Again, we have version 1 up to 9, and 5 is most popular. So here you can see that, for example, in the popular version, that's version 5, what are the content and again the description. So we can go and check the addresses, we can check the next hop, the SNMP index, packet flow, total number of L3 byte, system uptime, TCP UDP port, if you have any flag. Again, you can see these key information. Again, the argue is there. So still the version 5 is not giving us each and everything inside the flow. If I want to see more and more number of fields, then what version we should use? So here you can see in this chart that version 5 is giving only 18 exportable fields. There are some limitation as well, that they are fixed with IPv4, they have fixed level length, single flow cache. Okay, so there are advantage with version 5, but there are certain disadvantages as well with version 5. Then we have version 9. Now version 9 is template based, it is much more robust, it can have the MPLS and BGP supported fields as well. It is going to support 104 fields. So you can see 18 versus 104 fields. But again, it has limitations that IPv6 flows are exported inside IPv4. Fixed length field use more memory, slow performance, single flow cache. So you can see, although you have ease of use, but on other side, it is consuming much more resources. So if it is easy to use, it is giving less number of fields. If you are using more much robust uh, options, then at the rate of high memory and slow performance, etc. Okay. Again, we have the flexible NetFlow, that is again using version 9. So you can think that version 9.1 or 9.2, that's a flexible NetFlow. This supports flow monitor, supports selectable key fields for IPv6, supports NBAR. Again, this NBAR network-based application recognition protocol, and uh, even the Cisco who has made this NBAR just to analyze the application. And I have given so much theory related to NBAR in my SD-WAN curriculum, because if it is a Cisco device, so for example ISR or any type of Cisco device, at that time uh, NBAR 2 can recognize the metadata of application, and they can recognize up to 1400 or 1400 plus applications, rather than the other vendors. Also, they are claiming that they can recognize more and more. But again, uh, we can recognize the application with the NBAR, and in this NetFlow these are supported. In this session we are going to learn about the terminology, and we are going to learn that how we can collect all these pieces, and then we can go and configure the NetFlow as well. So let's start. First of all, flow. We know that we are going to analyze the traffic flow. So whenever I have a flow, obviously that particular traffic flow or flow having various type of key and non-key. So what does it mean by key and non-key? We will go and understand that. But at this point of time, we can think that there may be some mandatory things. There may be some optional things that we want to collect or measure, correct? So according to that, we can categorize these as a key and non-key, that we'll see. Starting with flow, they have the key field like source, IP, destination, IP, port number, protocol, etc. Then we have the flow record. Again, the record you can think as a office and file system. In a file, you're putting all the records of all the customer or clients. So like that, you may have a record what you want to collect, and this record may be key values, this record may be non-key values, or mix of both, correct? So generally it is key plus non-key value that is there in the record. Then we have flow collector, where you want to collect this flow. What is your destination server, that we can go and give the collector IP. Template based configuration, nowadays we are using. Even if you go and check the SD-WAN configuration, inside SD-WAN we have, nowadays we have option for NetFlow plus the SD-WAN own cFlow template. So both the things are there. There we need to create the template as well. Template is again the format where you are putting various parameters. Then the exporter is nothing but you are going to collect the information, and you have the exporter where you want to analyze all these things. Finally, the NetFlow generator, that is nothing but who is going to generate the flow. That's the devices to whom we want to analyze the flow. Okay. Now again, all these terms, when we are going to do the configuration, at least when we'll see the configuration, we'll find that where we are going to use all these configuration options. The traditional NetFlow configuration is very easy and straightforward. What you have to do, that you go and first of all define the export version, then who is your destination and the port number. So destination IP and the port number. This IP is your NetFlow collector IP, maybe any type of server. Which interface you want to enable, I can go and use IP flow ingress, I can go and use IP flow egress. So both options are there. Let me quickly log into the device and let me show you that how you can go and do these configurations. So here I am, I can go to the flow export say version, and here you can see that we have 1, 5 and 9. I can go and use 5. Then IP flow export destination, I can go and give 192.168 say 56.1, that's my server, and then I can go and give the port number say 2055. Then I can go and check the interfaces. So I have interface say for example 15, and I can go and use IP flow And here you can see that we have option. First of all, I should make this as IP interface, because by default it was the L2 interface. And then I can go and use IP flow ingress. If I want, I can use IP flow egress as well. We can go and check the configuration, and if you want to filter, you can use the flow option. So here you can see that it's very easy and straightforward that you can go and do the configuration for the traditional NetFlow. Now the next very important thing we have is the flexible NetFlow. Most of the places you will see that we are using the flexible NetFlow, and the key term there is that you should know that what is your key item versus your non-key item. So we have the mandatory and optional things. Anything that will start with match option, that will be the key field. So TOS, type of service, protocol, source address, destination address, port number, etc. Then anything that is collecting, that will start with the collect option, that will be the non-key item. Correct? So TCP flag, byte long, packet long, absolute first, etc. Again, this also, if you want to do the configuration, so now you can go and give IP flow and what version you want to do here. So IP flow export version, say for example 9, and then we can go and use flow, and let's do the configuration for this as well. Say for example flow record, and we are inside the sampler, say match, and so here we can see that with this particular version, and here you can see the version of the image, the 12.4, flexible NetFlow is not supported. So what we'll do, that we'll check this configuration in the other version where we have the FNF support. So here you can see that you can go and create the flow record. Again, we have learned that NBAR 2 is supported inside version 9, and whenever we have this network-based application recognition software or the feature, nowadays Cisco has launched the NBAR VM as well, that you can check inside SD-WAN software module inside Cisco software downloads. So now we have this feature to analyze the application, how actually it is analyzing the application. So here you can see that whenever the traffic will go and hit the router or the device where you have enabled the NVAR capability. So suppose someone is surfing the website and then the packet will go and hit this device and NVAR is enabled as per this record. So here you can see that flow record has IPv4 source address, destination address. The key thing here is that they are matching the application name as well. So once they have the application matching criteria enabled inside the NetFlow, then they can go and hit and match that application. And in the flow, certainly you can go and see that you have the source IP, destination IP, everything, and then you have the application matching name as well. Okay, so that's the power we have with the integration of NetFlow with flexible NetFlow with NBAR. Okay, so NBAR is giving us much more visibility inside the flow of that particular traffic. All right, so how we can go and configure here, you can see that you can go and create the exporter, who is your destination where you want to export. Then you can match the key and non-key items like match and collect keyword. Then inside the monitor, you can call point 1 and point 2, that is the flow exporter and flow record. And then obviously you should go and apply over the interface. Okay, so these are the steps that we can go and use to enable the NetFlow. Now there are some use cases. The point here is that at what particular point and how much match statement we need, how much collect statement we need, and that depends upon what exactly we want to analyze. So for example, in client and server communication, here you can see that for the client server state, you can go and match the DHCP protocol, addresses, source port, destination port, and in the non-key item, the interface output, bytes, packets, plus the application name. So here the application name, we have the account on resolution. Again, this NBAR, it is showing the capability of NBAR, that is giving you the visibility for the application to check the application flow as well. Now we have complete replacement for IP accounting keyword, where you can go and check which IPs are using how much volume. So here you can see that we can go and use this IPv for DHCP bytes long. So that's the counter bytes long, counter packet long, and then they collect application name. So we have application visibility, and then we have the IP accounting, and then we have the DHCP matching as well. If you want to analyze the QoS queue hierarchy for QoS, so this is the QoS configuration. We already know about QoS. We have learned about that. So you have the parent and you have the child policies. Inside child, you have the class map like this, and inside class map, you are matching certain DHCP. Now, how inside the flow we can match it? So again, in the optional field, we have an option that we can go and collect the policy and QoS policy, QoS queue and drops. Again, this is just for the reference that how the protocols fields are getting matched with which type of FNF statement. So we can go and collect the application called SNMP server, sender, POP, NNTP, SIP applications, HTTP applications. So we have long list of application matching criteria that we can go and check inside the flow. Now, how it is working behind the scene, here you can see that in any of the flow, they will go and extract the URL, the agent, the application refer, the application HTTP host. That's the capability, and that's the visibility we have with respect to NBAR. And finally, we have one uh, example here that you want to have this record option. So here you can see there's flow record, and in that record what you want to match. So you want to match the data link MAC, the destination data link MAC, VLAN, TTL toss, protocol, source address, destination address, and then finally you have the optional, that's the key and non-key option as well. Those things you can go and match. Now let's see that how we can go and do the configuration for flexible NetFlow. I'm running 15.0. So first of all, I can go and give the exporter version, and then we can go and create the flow, and then we have this exporter. So let's do that. Say flow exporter, my exporter, and then I can go and give the destination, that is my local server as a destination. Then we should go and create the flow record. So for that we have flow record, say my record, and then I can go and match various parameters. So what is the destination address, then match. These are the key values that we are matching here. Source address. Again, you can see that with match option, what are the things you have. So we have the option to match the application as well for the NBAR, and I can go and use the match and then the application name, and we can leave it. So system will automatically understand that which application is going, and it will go and match. Again, you can see that inside the match you have application, data link, flow, interfaces, IPv4, IPv6 routing, and the transport as well. Say routing destination. You can see that we can go and match the AS and the traffic index as well for the BGP. So we have these robust options related to match. Then we can go and use the collect. Inside collect, we can go and use the counter for byte, counter for packets. Again, you can see with the collect option, we can go and collect the application and then the name. Now flow record field is already present. So already we have given this field in the key. So it's not required to give in the non-key as that we have already defined in the key. But you can see that we have options related to uh, non-key item as well. Some of the options are there in key as well. If you define in the key that has a higher preference, that will not go and take in the non-key. Alright, so once we define the flow record, then we can go and create the monitor, and inside monitor we can call all these things that we have created earlier. Means we can go and call the exporter, that is my exporter. I can go and call the record, that is my record. And then finally you have to go and apply this monitor over the interface. So I can go to my interface and then I can go and use this monitor word, that's a my monitor, in the input direction. And it is taking a while because we have enabled the applications as well. Whenever you are enabling the NBAR, that's indirectly the application, it will go and take some time to apply it. Once it is done, then we'll get the line. So these are the things that we should go and check and enable. So define the exporter, define the record, call inside the monitor, and then apply it. I can go to the output as well, and then we can go and check show flow monitor. If you know what is your monitor name, you can go and give the monitor name. Okay. Apart from that, we can go and verify the flow interface. If I know the interface name, I can go and check. Then we have the flow record. If you have multiple records, you can go and select, and you can selectively go and check this. Okay, so this is the way that we can go and enable the flexible NetFlow. That how we are going to use a DNS Center assurance feature to provide troubleshooting, to provide actually fast troubleshooting. Uh, do we have full visibility? Can we do the monitoring, management, etc.? Uh, One of the key feature that we have in DNS Center is that we have capability to do the proactive troubleshooting. Proactive troubleshooting means that at the moment the issue will come, you have insight that what are the 4 or 5 steps that you have to do. So suppose depending upon, say suppose if you have level 1 and level 2 engineers, or even level 1 engineers, and they don't have broad knowledge of how wireless is working, routing, switching, working, other application experience related issues, client related issues, etc., etc. Everything is properly categorized inside the DNA, that you can go to the dashboard. You have to reach out to that particular client or network device or application. You have to do few of the clicks, and then you will reach to up to the level 1 plus level 2 troubleshooting. Now again, if you are not figure out how to do the troubleshooting, how to resolve this issue, then option is there that we can raise the tag case and proceed. All right, so here you can see the DNS Center workflow. It has design, policy, provisioning, and assurance. This assurance is again very important. So once we have the network up and running and setup is ready, then we have the assurance feature that will provide us the quick remediation options, and we have very high level of telemetry. So we are collecting all the information. We have intent-based networking as well. So we are getting the information from a policy plane. Uh, we are getting the network health and the device health. We will see that in the lab. I will log into the DNS Center and I'll walk you through all the options that we have in the assurance. Now in the workflow, again the design means you're going to do the standardized network architecture, site building flows. Again, it's like hierarchical model, that when you're doing the design, suppose if you want to add one AP, then you can go to the site, then you can go to the area, then you can go to the floor, then you can add it like that. It's all options are there related to design. So is it a border leaf, it's a control node, it's a WLC, it's a AP, it's a edge, etc. Everything as per design you can go and implement. Then we have the policy plane. Remember, we have different type of planes in ICE. We have data plane, mostly the edge nodes or edge devices, they are working as a data plane, but the underlying technology is VXLAN. Then we have the control plane. Again, your control routers or control plane routers can work for that. So for that we have Lisp protocol, where you have the MS and MR, where you are putting all those information related to endpoint, and then it is working as a route reflector. We can say that if some client they don't have information about the other endpoint, that can be reflected to the other side. And then finally, obviously, we have the policy plane, that is nothing but the ICE integration. Now, because we have the ICE integration and we know that how robust that ICE is, and ICE can have all the information and then it can take decision as per the ICE policy. Nice thing here that the ICE is integrated with DNA, and then in the DNA I can go and create the policies and then I can push it. So no need to go and log into the ICE and then check all these policy. Rather than from single dashboard, we can go and check who gets in, who talks, how, and application treatment. Correct. So who can talk to who, and obviously there are much more information. These are just the high points that you are seeing here. Finally, we have the provisioning. We have automatic deployment of site profile, compliances management, inventory, lifecycle management. So in short, that with help of DNA Center, uh, we have full capabilities, or we can track the experience related to network, experience related to services, experience related to client. So what are the key component we have in the network, or what are the key component we have in a broader picture uh, with respect to enterprise network? Nowadays this term is not used network, but people are telling about infrastructure. So now the companies and the MNCs, they are looking for the infrastructure engineers. So what does it mean? It means that not only you know the routers, switches, firewall, WLCs, ICE, etc., but you are knowing some other vendors, uh, say knowledge as well. So for example, you know Palo Alto as a firewall. Maybe it is one of the best firewall. Then some other services from other vendors, that is the best. Maybe some data center technologies, that is very good, etc. Okay, so the ICE from Cisco, uh, they are integrated with DNA, and with that integration, again, if you go and read more, you'll find the DNA has been integrated with, or can be integrated with ACI as well. It can be integrated with SD-WAN as well. So that means in future you have one dashboard, and from that dashboard not only you can manage the campus area network, that but you can go and manage the ACI, you can go and manage the SD-WAN as well. Okay. So now we are going to discuss about the assurance feature. Here you can see that you can go and click to the assurance feature. Here you can see that you have in the workflow design policy provisioning assurance. So you have the design policy provisioning assurance. Obviously you have the platform option as well. But you can go to the assurance, you can go to the health. Now what type of health you can have? You have overall health, you have client health, application health, network health. Apart from that, at this point of time, if you go and click here, you'll find that you can go and check the sensors information as well. So I'm going to log in, and not only here you can see that you can go and check the health of the devices. You can log into the devices. You have the tickets as well, and if you have the integration of your DNA with the monitoring tool, say for example, ServiceNow. So here you can see that this ticket will go and automatically when P1 will raise, And suppose you have the P1 ticket, obviously you want to go and troubleshoot. So for the basic level troubleshooting, it will tell you that, oh, you can check the ICE is up and running. You can check the, do you have route related to ICE? If not, you can run this command. So it will go and run show IP route for the ICE server. Do you have IGP? Do you have EIGRP or other protocol running or not? So these things by default will be there. Okay, so you will get 4 or 5 options, troubleshooting options, that if this is the case, this is the thing that you should check. And suppose if you are not able to resolve it, then you will find 4th or 5th option, that open a case with tag, and you will get the tag numbers as well. Okay, so in the assurance, again, you can see that you have the health option, you have the dashboard. If you have any customization for the dashboard, you can do that. Then you have issues. If you want, you can see all the issues with single shot. Again, in the health, you can see overall health, network health, client health, and application. And it's a big thing. It's a huge thing, because what is happening, and that's the truth at the moment in the organization. So someone who is managing the client, he don't know the application, how it is working. Someone who is working in the network, they don't know the client side of things, like AD integration or maybe AD plus ICE integration, how it is working. So network simply means at this point of time, again, that has been changed now. So router and switch and firewall configuration, or maybe some other network devices like F5, etc., etc. But now the area of network, or a scope of network, has been increased. So we should go and learn about the application behavior as well. So when a client, so for client, what is important? Client want to access the application, but in between we have network. So here you can see all 3 points are connected. So client is using application with the help of network. Everything you can go and check. So what is the status, health, everything related to application, the status health, everything related to client, the status health, everything related to network. And that's the power we have with the DNA assurance. Okay. So you can go and check not only the wired but the wireless. Again, you can go and check the user and the user behavior, what the user can do, and what type of uh, issues that user can have. All those things you can go and check. So what I'm going to do next, that I'm going and logging to the device, and then in the DNA, and then I will walk you through all these options that you are seeing here. All right, so let's just stop now. Now we have lab related to DNA assurance feature. You can log into the DNA dashboard, and once you log in, you will find that you have this nice dashboard where you have options related to design, policy, provisioning, assurance, and platform. Now once you go inside the assurance, again you can see that you have the dashboard where you are getting the overall health. So if I go here and scroll down, you can go and check first of all the network devices, the wired client. Again, this is the summary for the network that I have. Apart from that, you can go and check what are the top priority cases like P1, P2. And if you have the integration with ServiceNow, obviously you will get those information there as well. Now we have option that we can go and check the geographical location of these devices as well. So these options we have. Now nice thing about this place, once we reach to this particular place, then here in the dashboard you can see that you have options related to health, wireless sensor, rogue management, and the dashboard library. Now inside health, and this thing is a big, all the time we used to discuss about this, that what exactly we are looking for to do the troubleshooting. So what we want, that we have the client, and client they're using the application, and this application is used by the IT infrastructure. Okay, so in between you have network. So not only that, you can go and check the overall health of client, You can go and check the overall health of network. You can go and check overall health of application as well. And that's the assurance we have in the DNA. So we have full application visibility as well. So by default, it will be overall health, but if you want to go and check the network health, you can go and click here. You have network, you can see the latest and the trend. Now here you can see that we have the category of all the networks. So the fabric control plane, the fabric border, the edge and wireless devices. Everything is showing green, means everything is good, 100%, everything is good, up and running. Now suppose if you have issue, obviously it will show you the health, poor, fair and good as per the diagram, and you have the other options as well. So let me show you that what you can do. Suppose one of the device in the fabric control node is down, what you can do, or suppose if it has any issue, you can go and one by one you can go and check those devices. So you can see here that from this dashboard, again if you go and click on new pop-up will come, again you can see that good is 8, and if you want to check the information about all those 8 devices, so here it is showing that you have these switches. So here you can see in the pie chart that what are the devices in different color code. You can go and check the device model as well. You can go and check the device OS as well. So networking, devices, model and OS, it is telling. Now if you scroll down, you can go and have the list of all the 8 devices, and in these 8 devices you can see that still you can go inside those devices. So here you can see the device name, the model, the OS, IP address, overall health. And remember, this health scores that you are seeing here, this health score is nothing but, sometimes it is referred as a quality of experience, but you may have different color code. So here you can see that good is if the score is 8, 9, 10. Fair is in between, say for example 7, 6, 7. Bad is less than 5, so 0, 1, 2, 3, 4, 5, like that. You have your health scores. But yeah, remember, if it is 8, 9, 10, it's good, it will show you green. So overall health, you can see here the memory utilization, the CPU utilization, the data plane, the control plane, and from same dashboard, that means single place, you can go and get all those information, correct? And that's the power we have with these. Now we have the export option, that we can export this output and then we can further check. Now suppose if I'm interested about this campus core, I can go and click. Then what will happen, this campus core page will come and open, and then we can go and further check their device 360 health. So still you can go and check more and much more information about this. So here you can see the graph on top, you can see that events and health. And once I go and click there, and if I scroll, so we have the time range, and with that time range, what is the memory utilization, the CPU utilization, the link, each and everything it is showing, correct? So we can go back and forth into the time and we can go and check that. So overall this device is showing the correct behavior, correct? All right, so once we can do this, again you can see that if with that particular device, if we have any issue, so it is showing that 0 issue reported. Let me scroll up. What is your neighbor topology? If you want to do the trace route, what is the application experience, the device info, interface, fabric event viewer, each and everything we have at the single place. So here you can see this is the topology, and if you want to do trace, you can go and do the trace as well. So this is your source IP, and if you have any destination IP, you can go and start the trace. Now you can see that how it is going, where the ACL is blocking, who is the source, who is the destination, where you have the kappa app tunnel, each and everything we are getting from this path trace, means how actually the packet movement inside the over the path, over the network. Application experience will see separately this application experience. But yeah, we have all those information, graphical information we have, but still if you want to run the CLI command, so we have this run command option where we can go and check various things. Say for example, if I can run few of the commands, then IP route, etc, etc. So we have this option of the command runner as well, where we can go and run that command. Again, if you want to check more information, you have this option, you can go and check more information. So this all information was related to one thing, that is the assurance and the health and the network health. Then you can go and check the client health as well. So client means that how many clients you have connected at the place. In our topology, all the clients are connected. You can see that 90% of them over the wireless and 98%. This is just the health score. But in our case, mostly the clients are connected with the wireless network. So let me show you a few of the client and then I will move on. So if I scroll down, here you can see that I have clients and I can export those clients, wireless and client. Let me do wired as well. Let me apply this filter. So on top you can see that you have filter as well, and few of the clients are over the IoT, few of the clients are in premises as well. It is showing wired. So let me go back to the wireless, and a nice thing here you can see that when you are doing the filter with wired versus wireless, the wireless clients, they are showing you this type of wireless icon. Correct. So we have most of the client over wireless network in this scenario, and even you can see the health score as well. So let's see the health score with poor rating, poor health score, that is 3. So one of the health score, one of the client has poor rating. I can go click and open, and then we can analyze. So now you can see the status, the RSSI, the SNR, the AP, the failure, re-authentication. So what's the issue? Why this health score is less? So for that you can go and check that there are issue with him, and here you can go, this is the iPad with this particular client, the device info, the MAC, the SSID, those things are there. Then the RF, the connectivity. So here you can see the TXRS, the DNS, request response, and then here you can see clearly, you can see that how easy it is to find at least where is the problem. So now if I scroll down, you can see this, you have the event viewer, and event viewer, it is telling that okay, the status is failure, this is the username, and when you try to log in, there may be chance that it is not able to authenticate maybe with the uh, ICE servers that we have. So here you can see the onboarding. So let me show you the full picture. Re-authentication, you can go and scroll. EAP timeout is there, broadcast rekey, all this try to establish a connection, but there is problem. So every day there is problem with the authentication. Correct. So we can understand this thing. Still, if you want to do the trace for this particular client, and if you know that where is your ICE server, are you able to reach to the ICE server or not? If you have that IP, so you can go and give that IP and you can start that. So here you can see the trace route, and this is the source port not specified. Obviously we haven't specified. So it has reached here over the cap web tunnel, and again we can go and check more and more about this. So let me show you this, the cap web tunnel, the laptop switch, etc, etc. So let's see more about this, that why exactly we have the issue. But here you can see the issue is related to authentication failure with this particular WLC, and we have the EAP timeout. Client is de-authenticated, authentication is done, and here we have the issue. correct? So clearly we come to know what is the issue, and then we should go and check the WLC configuration. We can go and check the ICE configuration to overcome this. With client again, no need to check the application experience, because again we have this separate application experience option or tab. But still, if this client is using some of the application, here you can see that MS update and Outlook update, the health is 5. So again you can go inside this, and this place you will reach with the application assurance application health as well. But related to this particular client, you have this particular health score that you can go and verify. So you can see that how deep we can go inside the client, and we can check various parameters related to client, correct? Now finally go and let's check the health of the application. So now you will get the list of the application. Obviously we have much more application, and here you can see if I scroll down, so application, and whoever application has low health score, it is showing here. And you can see that bad is 1 to 3, fair is 4 to 7, and 8 9 10 is good. Again you can see this much of data has been used, and again this business application or application usage in percentage you can go and check. Still we have this option, we can go and check view details for those applications. So business applications 62%, this application this much percent, how much of the percentage kbps bandwidth used, each and everything we are getting at the one place. So once we are reaching up to application health, and if you want to see the uses of the application, here you can see the ratings, means the health score. And again, if you go and click inside any of them, you will go and get much more visibility and the information about the uses of that particular application. Okay. So thing is that if you go and start working on this, and if you spend few of hours, we will be very much in a position to find the issue, and then we can go and set the issue as well. Now even there is no need to find the issue. Why? Because automatically the platform will tell you that what issues you have. So suppose if you have this issue, it will come here. But if I scroll down here, you can see that you have P1 issue related to ICE server with a border router. So now if you go and click here, you will see that you have open issue. What is the issue? So again, if you go and click, it will show you that the fabric edge WAN cannot reach to the ICE server. Okay, so what type of test should I do? Now you here can see that's the power of DNA we have. So it is telling that verify your ICE server is up or not. Then verify that do you have route to the ICE server. So you can go and click run, and it will do show IP route for the ICE server. And all green means that you have the reachability with the ICE server. Then verify do you have the IGP running. You have your IGP neighbors are up and working. So here you can see they are up and working. Then finally, if you have done all these basic troubleshooting, means configuration is correct, reachability is there, no issue with the physical interfaces, no issue with the hardware level, etc., etc., then we can go and raise a tag case to work on that. So they have given the number to raise that case and check on that. So you can see that all three things has been covered nicely here inside the health network client and application. Even you can go and check the wireless sensors health and scores as well. So you have the separate category for wireless. You can go and check the onboard test, the network test, application test, etc., etc. All right, so this is the nice and very useful capability we have inside the DNA assurance. In 4.4, we have to understand about DHCP related to IPv4 and IPv6. So let's understand DHCP services related to IPv4 first, and then in the next section, I will go and understand with respect to IPv6. As we know that to get the IP addresses dynamically, we have DHCP services, Dynamic Host Control Protocol. But what is the process? What is happening that before starting the DHCP process, means once the DHCP process will start, there are certain steps. So the client, you'll find that there are client and server. So suppose you have the DHCP server somewhere. Let me have some space. So suppose you have your DHCP server. This is my DHCP server. And then it is in the network where the client, they want dynamic IP addresses. So suppose I have client 123. So first of all, they are sending the DHCP discover packet to the server. That means they want some sort of IP address. They want some options inside the IP, or along with the IP, they have some other options as well. Like they're looking for default gateway, DNS, time servers, Win server, etc. These are the options that may offered from the server, DHCP server. So you can see that the broadcast packet, that is the DHCP discover, will go to the server, and then server will send the DHCP offer. So the DORA process, let me write here DORA, discover, offer, and then request and acknowledgement. And here you can see discover, offer, DHCP request, and DHCP ACK. So he is sending the first packet, that is the discover, then server will respond with the offer IP. Now once those clients, they are okay, that okay, I'm okay with this offer, offered IP address and other options from the server, then they will go and send the request that, okay, I am good with this. This is my DHCP request. I want this. And then finally, the server will send the acknowledgement. Okay, you got it. You stick with it during this period. This is the lease, etc. Okay, so this is the DHCP process, the DORA process with respect to IPv4. And along with this, DHCP server can give some options as well, options related to configuration, related to default gateway, DNS, time server, Win server, etc. Okay, we are going to do a small lab, and in the lab, I will take, um, let me show you the diagram here. Actually, I want to use two routers, and I can draw that diagram. So you think like this, that you have a router 1 and router 2, and then you have client. Suppose this is client 1, and here I will take client 2. Okay, so router 1, I'm going to install, or I'm going to do the configuration related to DHCP server. Router 1 will work as a DHCP server, where we'll go and do the configuration like this. Okay, so we have to go and give the pool, then default gateway, DNS server, and then the optional configuration, domain name, and then the lease period as well. Like you want this IP to be stick with 1 day, 12 hour, or maybe 2 days, etc. Correct. And after that, again, they will attempt to get the IP addresses. Means after that lease expired, they will again start the DORA process. So we are going to see, check this in the lab, and in the lab, what I will do, not only that I will go and cover the DHCP related configuration, but I'm going to show you that how the helper addresses are also working in this process. So first of all, I will go and show you the first half of the lab. In first half of the lab, what we'll do, I will go and cover the DHCP process, and next half I will show you, explain you about the helper address concept as well. We are going to perform the lab task, and I'm going to show you both the versions here, variation. First of all, the DHCP, and then the relay configuration as well. Now, while we are doing the relay configuration with the IP DHCP IP helper address, as you can see. So at that time, it is forwarding the UDP traffic. You can see it is going to forward these port numbers, UDP port numbers. But if you want to stop this forwarding, we have option. We can go and use no IP forward protocol UDP and then the port number. Okay. So in the lab section, what I'm going to show here, you can see that we have this lab topology for IPv4, even for IPv6 as well. On router number 1, I will go and create the DHCP server configuration. And once we have the DHCP server configuration, then we will go and lease the IP. So this iOS 3, actually this is working as a host 1, and this iOS 4 is working as a host 2. Okay, so we need to go and do the complete configuration. I haven't done any IPv4 configuration here. So I will log into the devices and I'll show you all those configurations. Okay, now since here I have the DHCP server, and here you can see that that is the host. So suppose this host will go and request for DHCP server, how it will happen. So first the request will come to the router number 2 or iOS version 2, but since we haven't configured the IP helper address configuration here, so that's why it will not forward the broadcast packet, correct? So that means to get this particular device to get the IP address, we have to go to router number 2 and we have to do the relay configuration. That's straightforward. That is IP helper address and then the IP address of the DHCP server. Correct. So let's do this. I'll go and log into the devices. Here we have the device. You can see I have router number 1. I haven't done any configuration, but if you go and follow the lab topology, I just wanted to show you the lab topology as well parallelly. So we should know that what interfaces, what configuration we want to do. First of all, we are going to do this portion configuration. So interface gig 0/1. I'll go and give the IP address 192.168.1.1. That may work. No shut. And then IP DHCP related configuration. So IP DHCP, I want to exclude. I don't want 192.168. Oops. 192.168.1.1 till 192.168.1. Maybe 9. This range I don't want to give to the host, so this is excluded. Correct. Then we can go and give IP DHCP pool, say my pool, and here we can go and give the default router, that's the gateway 192.168.1.1, and then we can go and give the network command 192.168.1.0 Now here we can go and give the optional commands. So here you can see that good amount of options. We have like DNS, like domain, etc. Even the lease as well. So domain name, we can give any domain, mydomain.com, something like that. Then DNS server, 192.168.1.6 is my DNS. And then we can go and give the lease as well. Lease, you can see in days, in infinite, is always it will get that IP. So 1 day and 4 hour. Okay, so we have created the pool. Inside the pool, let me show you that. And in the section DHCP, let's see. Okay, so here you can see this is my IPv4 configuration that we have given. Correct. Now, what we can do now, we can go to the host here. This is working as a host, and let's see. Show IP interface brief. Now, this host, to get the IP, I should go to the interface gig 0/1 IP DHCP IP address DHCP we can do, correct? Mistake the IP from the DHCP server. So now the DORA process will kick and it should reach to the gateway to get the IP. Now here, first of all, this guy should, so you can see it is working here, and you can see the IP is starting from 110 because up to 1.9 we have done in the exclude list, correct? Now if you go here and if you check show IP DHCP binding, you can see that you have the binding table and the information about that. That is one portion, correct? That it is getting the IP this side. Now, what about the configuration related to in between R1 and R2, correct? So let me fix here. Let me give some more space so I can go and show you the topology. So what about that this particular host, that is host number iOS 4, host number 2, how it will get the IP? Because you have one DHCP server router number 1. So first of all, I should go and do the network related configuration. Gig 0/2 is the interface. This portion configuration I'm doing. So here I'll go and give the IP 192.168.2.1 2550 and no shut. And apart from that, I'll create a static route configuration just for the sake of simplicity, but maybe you have any dynamic routing protocol that may work. 0.0.0.0.0.0, that's the default route pointing towards the next hop, and next hop maybe 192.168.2.2. That's the peer IP. Likewise, I can go to this router and interface gig is 0/2, IP address 2.2, no shut. Let's see, where is the misinformation and no shut. And then I have one more interface gig 0/1 where the client number 2 is connected. So here also I can go and give the IP address 192.168.3.1. That is going to be the first hop for the host number 2. Now what next we want to give the IP route, default route towards his gateway that is pointing towards router number 1. 192.168.2.1. Great. So now we have full routing configuration. We want to do the configuration related to relay, correct? And for that, so here you can see that you have to do the IP helper address configuration. That's it. Where you want to do, from where the request will go, it pointing towards the server. That's the gig 0/2. So if you go to gig 0/2, correct, and you can go and do IP DHCP helper. Let's see, IP helper address and the IP DHCP server 192.168.2.1, correct? That's the server. So I have done the configuration related to helper address. So the broadcast packet should not stop. And if I go to router number 4, means that's the host number 4 actually, and it should get IP. So let's see, the interface is interface gig 0/1, IP address DHCP, no shut is already there, and we can wait for a few seconds. So DORA process will kick on and we should get the IP address. Here it is, it seems, yeah, 192.168.1.11. And now if you go to the DHCP server, if you go and check show IP DHCP binding, you're seeing this and this, and you can see that this is in different subnet, and this is in the same subnet. Even if you have different subnet, with help of helper address or relay agent, you can get the IP address. All right, so this is the lab related to IPv4. Let's just stop here. Next section, we have IPv6 DHCP version 6. The lab topology will be the same. Router number 1 will work as a DHCP version 6 server, and then iOS version 3. So router number 3 is host 1, and router number 4 is working as a host number 2. And in router number 2, I'm going to do the configuration related to the relay agent for IPv6. So let me quickly show you the configuration in the notepad. The same I will upload with the recording. You can see router number 1 configuration. Same configuration I have used over the device as well. Router number 1, go and enable IPv6 unicast routing. And once you have unicast routing enabled, you can go and create the pool, IPv6 DHCP pool, give the name for the pool, and then DNS server, domain name, etc. Then here you can see that I'm creating the pool, and this is for a stateful. That means that from this pool, so this is the address inside the pool, the addresses will get assigned to the devices. And then you can see the DNS and domain means very much similar that what we have done for IPv4 DHCP configuration. So we are going inside the pool, we are giving the pool IP address, we are giving the options like DNS, domain, etc. Then as per topology, so our topology is, so let me quickly show you the topology here. You can see the topology R1, the LAN network for R1 is connected with gig 0/1, and then point-to-point network between R1 and R2 having interface gig 0/2. So let's go back here. You can see the configuration. So over gig 02, that's point-to-point network, we have this global IPv6 address. It's straightforward that we are giving the IPv6 address over the interfaces. So either it's a gig 02 or it's a gig 01. We are assigning global IPv6 addresses. Okay, and once we have the global IPv6 addresses, I am creating IPv6 default route. Again, same type of configuration we have done for IPv4 DHCP configuration as well. Now in the LAN interface, one change is there that you can see that we are giving IPv6 ND other config flag. That's just the configuration for the flag. And in the point-to-point network, you can see that I'm giving the configuration as IPv6 DHCP server, server name, RT stateful. Okay, so most of the configuration we have over router number 1. Then we can go to router number 2. Router number 2, first of all, point-to-point IP configuration. So this is the IP. It should be reachable from router number 1. We'll do the ping test. And then over the LAN interface, you can see the LAN interface. We are giving the IPv6 address, but this LAN interface is going to work as a relay as well. So that's why you can see that we are giving the relay address, we are giving the IPv6 address, that's the DHCP version 6 address, and then the interface associated with that. Again, while we have done this configuration related to IPv4 DHCP, that time we have given the command very straightforward, IP helper address. Correct? Here the configuration command is little bit different, IPv6 DHCP relay destination. Then here also we are giving the ND manage config flag, and then the ND prefix no auto config. These are the only changes. Now over the host, what we want to get the IP related to IPv6 related to DHCP. So you can go and enable the IPv6, and then you can go and give IPv6 added DHCP. Okay. So here you can see that router number 1 configuration, and in router number 1 you can go and check IP DHCP bindings, and you can see that it has assigned, let's see how many addresses. So one IPv6 address 1825, and other IPv6 address is complete IPv6 address. The last portion is 722F. So if I go to host number 1, and if you go and check show IP v6 interface brief, you can see here that it has IP 1825 coming from the server, IPv6 server, DHCP server, and 1825. Now if you go and check the relay, and if you go and check the IPv6 address over the other host, so here you can see the other host having address 722F, and here you can see a release from here. Okay, so this is the way that you can go and do the configuration. Once you have the configuration, you can go and check the release IP and the details related to IP release as well. All right, so we are good here. We can go and stop this.
Hello everyone. I'm going to give you offer related to CCIE lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have a SD-WAN full-fledged lab. Actually, this is complete CCIE Enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in CCIE exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular Eve NG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SD-WAN, you need to work on vEdges and the vManage. Release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCIE exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA, because in this Eve NG lab, we don't have Cisco DNAC integration, and you can't do ICE lab as well, because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCIE exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide, how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCIE exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCIE exam. So what is the cost of this? Because I'm offering this for the students, so I put very little a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request. Let me write here, Ratnesh721, Kumar721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EVNG software, or the file where you can go and practice your CCNA, CCNP, CCI, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file, and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also, you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCI, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, and CCNP, again, we know that we have N core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market, so you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best.